First of all, welcome to this webinar of RINNO project and in particular about the RINNO suite. Nice to meet you all, and I'm Elisa Crocco from RINNO Consulting. I'm the project coordinator, and we can start the webinar with a brief introduction to the RINNO project, and then I will leave the floor to the expert within the RINNO consortium that will show you the functionalities of the RINNO platform. So I will share my screen. Can you see my screen?
Yes.
Okay, perfect. So yes, as I already said, this is a brief introduction to the RINNO project. About the project, the RINNO project title is an augmented intelligence enabled simulating framework for deep energy renovation, delivering occupant-centered innovations. The program under which the RINNO project is funded is the Horizon 2020. The type of action is an innovation action. The grant agreement number is 812071. And the starting date is the 1st June 2020, and the end is August 2025. So the ambition of the RINNO project is to accelerate the deep energy renovation in the European buildings. So RINNO aims to transform the renovation market by delivering a comprehensive AI-enabled framework that streamlines the entire renovation life cycle. So from the planning and design to the retrofitting, the implementation, and the monitoring. RINNO introduced the cost-effective, low disruption, and environmental-friendly technologies, combined with the modular plug-and-play solutions, innovative business model, and digital tools to improve the performance, reduce renovation time, cost, and enhance occupants' comfort and engagement throughout the entire process of the renovation. The consortium is composed by 19 partners. 4 partners are involved in the basic applied research. Other 4 partners are commercial entities that will provide innovative products, solution technologies. We have also 1 software developer, 2 experts of construction methods, 4 end users, so 4 demonstration sites that will test and demonstrate and implement RINNO technologies. And then we have 3 experts in stakeholder engagement, dissemination, communication, and exploitation activities, and business modeling. Okay. So these are our demo sites in RINNO. As I said before, there are 4 demonstration sites. They are all multifamily dwelling in France, Poland, Denmark, and Greece. Okay, the objective of this webinar is to show to all of you how the RINNO suite works, because to achieve its objective that I said that I mentioned before, RINNO has developed an integrated digital platform, the RINNO suite, powered by augmented intelligence and support the entire deep renovation life cycle, from the planning, as I said before, to the implementation and monitoring. The goal of this platform is to reduce renovation time and cost while enhancing building performance and occupant comfort. So the RINNO webinar will demonstrate how the platform works and present its core tools and showcase the expected benefit of the suite. This is the webinar agenda. So first of all, we have this welcome and introduction of the RINNO project, and then we have an introduction of the RINNO suite due by our colleagues from CERT. Then we have the presentation of the 3 packages of tools, one from the design and planning, second one of the implementation, and then monitoring tools. Then we have 10 minutes for questions, dupes, suggestions, strengths and weakness of the platform. And then we have other 10 minutes regarding the completion of a questionnaire, and then the webinar closure. Thank you all for your time. And now I leave the floor to Vasilis to start to briefly introduce you the RINNO suite, and then we will pass through the tools that compose the platform.
You're muted.
You're muted.
Sorry, forgot about that. Let me know if you can see my screen.
Yes, we can see it.
Great, thank you. Okay, I would like also to thank you for joining today's webinar. As Elisa mentioned, we will be presenting the main functionalities of the RINNO suite, and then we'll start the functionalities, the purpose of why we use these tools, why we have developed them, and we will continue with presenting each component of the RINNO suite. So what's the RINNO suite? It's basically a platform that has been developed to support all stages of a renovation project. I believe we're all familiar with the challenges that are being faced for the renovation industry and the rates of renovation that are required in the EU area in order to achieve the targets, the climate objectives that the climate targets that have been set for 2030 and 2050. So as part of this of these challenges, the RINNO project has been funded in order to support the renovation stage. And part of the RINNO project, a big part of the project is the tool, the suite of IT tools that have been developed for the different stages of renovation project. So we have developed several innovations, either innovative tools that are not really out there in the market. There are no similar tools in the market. So we're introducing some new innovations or some innovative processes where tools are working together in order to give a more sophisticated result and more with a better potential for the innovation to succeed. The tools are targeting the different stages of the renovation, so the design stage, the construction / the implementation stage of the renovation, and finally the use phase of the building. As such, it comprises with the three main components for the RINNO platform. The RINNO suite of tools comprises three main components: the RINNO Planning and Design Assistant, we have named them like that, the RINNO Retrofitting Manager, targeting the construction renovation stage, and then the RINNO Building Lifecycle Renovation Manager, which targets the use phase of the building. A few words about the different components. Starting with the RINNO Planning and Design Assistant, this encompasses several software tools which support the design stage of a renovation project and enable the holistic analysis of alternative renovation scenarios. Holistic analysis is based on multiple assessing the renovation, assessing renovations in terms of their energy, environmental, user disruption, and waste management performance. And it facilitates also this component facilitates the selection of the best innovation scenario according to the user preferences and as well as the performance in the above aspects. It also produces an first optimum renovation schedule, which is then used for the actual implementation. So there's in order for this process, we have developed several tools. We have named them the digital twin tool, which conducts a first preliminary analysis for the building at the baseline and as well as the renovated state. And then we have a tool which is called Intema Building for conducting detailed energy assessment of the renovation scenarios, verified tool for conducting life cycle assessment, life cycle costing, as well as the techno-economic assessment tool, which assesses the disruption and waste produced during innovation. Then we have a decision support system which selects the best renovation scenario, and a job scheduling optimizer which generates the optimum schedule for work of the works of the renovation based on the user preferences, as well as specific site restrictions and constraints. Finally, apart from all these tools that are working together for selecting the optimal renovation scenario, there is another tool which is called the social LCA tool, which assesses the social impact of the renovation during the design stage, but also after the renovation as well. Moving on, the next step is the next stage that we have addressed is the renovation stage, the actual installation of the technologies and the construction of the building. This encompasses a set of tools which support the construction stage and aim at reducing the on-site time and cost of installation and construction processes. It comprises of a recommendation tool which suggests, according to the user preferences, the amount of work that can be completed off-site and on-site. Then another software tool which optimizes the process, taking into account the scheduling process by taking into account site constraints and refine the retrofitting schedule. Another component which enables the user to review, validate, and if necessary, amend the renovation schedule, as well as a monitoring component which provides real-time multidisciplinary KPIs and monitors the installation state, the installation process, and provides real-time multidisciplinary KPIs, and provides also update reports on the progress of the renovation. In addition, there is an augmented reality virtual reality tool which is used for the quick training of workers in a safe environment. And this whole sub-component, sub-platform of the main platform also is accompanied by a logistics platform which monitors and organizes deliveries on site in order to enable better control of the whole value chain. Finally, there is also another tool which was used for the scheduling of the works in the previous stage, may also be used in order to provide the detailed schedule of the building, of the renovation process. And with regard to the use phase, the final subcomponent of the main RINNO platform is called the RINNO Building Lifecycle Renovation Manager, and includes what we have developed as an implementation of a building innovation passport, which contains information for a renovation roadmap, as well as a logbook with monitor data. So it involves the monitoring of the use phase of the building, as well as additional tools which support the transactions between stakeholders and facilitate and also enable the use of the RINNO suite as a one-stop shop for acquiring technologies. So the main tools that are included in this stage of the renovation is the renovation roadmap, which supports the deep energy innovation stages, a building logbook, which includes a performance dashboard, including basic energy performance and environmental parameters, as well as a 3D viewer, integrating this real-time data from monitoring sensors with BIM information. Also, there's a marketplace where users may explore and purchase innovative technology solutions and services, as well as an online contract service, which are legally binding agreements that are created, signed, and executed digitally over blockchain technology. And also, we include also the social LCA tool, which may be used for assessing the social performance of the building after the renovation. Now we'll start with presenting and showing you the components and the functional and the layout of the platform and the tools, starting with the RINNO Planning and Design Assistant, which, as I said, it's the component that has been developed for the design stage of the renovation. The general process through the various tools that we have developed is by starting with a preliminary energy analysis of potential renovation scenarios, where we're using a tool in order to conduct some very quick analysis using minimum data, required data. Then we're moving on to a detailed energy analysis. We select specific renovation scenarios, and then we can conduct the detailed energy analysis. And then moving on to the LCLCC analysis, to the user disruption waste management analysis. In this process, we calculate specific key performance indicators regarding the performance of the renovation scenarios. And then using these key performance indicators, we select through the decision support system, select the best renovation scenario, and then the optimum sequence of works. And also, as an additional step, we include also the use of the social LCA tool in order to take into account the social aspect of the sustainability assessment. And now we have, you can see the how we access the tool. First, we have this web page where the user may enter the credentials and log in the platform, where they can access the tools. As you can see on the left-hand side, we have the RINNO Planning and Design Assistant, where when we click, we access different tools. And the first one is the Digital Twin tool, which conducts the preliminary energy analysis. This is a tool that has been developed by VTT, which is a partner in the RINNO consortium, and has been designed in order to provide some quick estimation of the building components by using minimal available data. So it has been parameterized in order to enter specific brief information, and it's able to deliver immediately based on the parameterization for each country. Some loads regarding the energy, the heating, cooling, energy consumption, domestic hot water, etc. So that was the first result. As we're moving on, we can also click in order to change some parameters and give a more accurate, let's say, description of the building, and more of course obtain more accurate results. So we can change different parameters such as the window sizes, the schedule, the air tightness of the building, the air change through ventilation, as well as the occupant profile. Also the U values of the building walls, of the building components. And if we change that, we also get an updated result, which is a more representative of the building under consideration. We can do this process and then save details, and then this will lead to the update of these values here, of these key performance indicators. Here we can see the estimated heating and cooling load for the building. Once we're happy with that, we can proceed to the next step, where we can consider specific measures for improving the building performance and for generating the renovation scenarios. So we have some predefined renovation measures, which we can click, can select them, and this will recalculate. This will update the building and will recalculate the performance under the renovated state now. And then there's going to be a comparison between performance of the renovation and the baseline of the building. Additional improvements may consider the hot water system, a PV, some solar correctors, as we see here, upgrading the HVAC system, etc. Also considering some auxiliary heating system. So this tool has been designed in order to provide a quick estimation of the renovation, of the baseline condition of the building, as well as the renovation, using minimum data, using few data, which this is what we have basically on a preliminary design stage, and we can get a fairly accurate estimation of the energy consumption of the building before and after the renovation. I think the main strength of this tool is the speed of the calculation, the fact that we can quickly consider various renovation scenarios and various renovation measures and get an estimate of the energy consumption, and also the accuracy, which has been considered and has been tested, has been evaluated during the implementation of the RINNO project, where we compared the results of this tool with the next one, which is the Intema building, which conducts the detailed analysis, and has been shown that has a fairly accurate, fairly good agreement between these two software. So using this application, we can have a quick estimation of the building performance, and we can have the where we can be sure, we can be quite certain that is a representative figure. Now, moving on, we can, after conducting the simplified analysis, the preliminary analysis, we can then move on to the next tool, which is the Intema building, and this conducts the detailed energy analysis. So the Intema building, the idea is that we first do the digital twin tool and we consider several renovation scenarios. Then we select the most promising ones and we assess them in detail using the Intema building tool. This is the layout. We can access the tool again from the left-hand side from the platform. Here we have run a few results, a few cases where we have the baseline as well as a few renovation scenarios. By clicking on this button here, we can access the tool, and the first thing that we see is the screen where we can load the IFC model, and if we have a BIM file, we can upload it in order to conduct the analysis by using all the data from the BIM, which saves us a lot of time. Here we have a case from one of the demo pilots of RINNO, of the RINNO project. Once we're happy, we can upload it and we can move on with the analysis. It should be noted here that we can do the analysis using the Intema building tool, regardless of whether we have a BIM file of our building or not. So if we have a BIM file, this will save us a lot of time by importing the geometry and the thermophysical properties of the buildings. If not, we can do this process manually. Next step is we select the location. So the location, we have a pre-selected one, which is the Lille in France. After selecting our location by selecting it on the map or by entering coordinates, we can refetch the weather data. We can load the weather data, and we get a message that the weather data for this location have been uploaded successfully, and this enables us to conduct the analysis. Moving on to the next step. We then set the parameters for the thermal zones. In this case, we can see once we import from a BIM file. Also, we can make the screen larger. We can take out the left-hand side panel in order to make the view better, larger. And then we can edit. We can set a new zone, or we can edit the zone here. We can select if we have a single zone building or multiple zone buildings. This is imported from a BIM file, as well as moving on to the next step where we have the building elements. This is where we define the building elements for our case study that we're examining. So in this case, there are materials that have been imported from the BIM, and these are the defined constructions. So first we define what is the construction that we have on the building, and by constructions we mean the materials for the walls, for the floor, and the ceiling slab. And then we are defining the walls. So this is a case where this has been imported by the BIM file, but also if we didn't have a BIM file, we could just define the geometry by entering the details of the walls. And then we can include information and we can assign the relevant construction. So the construction that was in the previous step is assigned in a new building. As I said here, we can also create a new wall and we define which zones this is in contact to. It can be in contact to the air, to the ambient temperature, or it can be in contact to an unheated space or a heated space where there's no heat transfer. And similarly, we do the same process for the windows and for the roofs and the floor. And we define the geometry of the building as well as the materials. And in this case, we have defined the whole building envelope. And having done that, we're ready to move on to the next step, which is to set up our heating HVAC systems. So in this case, we're considering a boiler for the space heating, and domestic hot water is provided by electrical heaters, while there's an air source heat pump for providing cooling. Also, we can select and set up different combinations of HVAC systems for heating, cooling, and domestic hot water. And on the bottom hand side, we also set specific information regarding the zone parameters, such as the heating, the cooling set point, the heating set point, the thermostat, infiltration rate, etc. Also, how many people are in the zone. Moving on, we're also assigning in this stage where I can also assign electrical systems, such as either renewable energy sources as well as specifications for the appliances. So we're defining all the electrical loads and electrical systems of the building. When we're happy with our setup, we can develop, in this case, we can see how we can set up a photovoltaic a PV system. And then we can move on to the next step, which involves, particularly for the RINNO project, we have also included the RINNO technologies where we can select them and parameterize them in order to be considered for the renovation. When we can see the different systems that have been developed in the project. We can select a few of them, and then moving on, we can conduct our analysis. Clicking on the left-hand side, we can click the simulation bar, run new simulation. In this case, we're loading some pre-loaded data for reasons of time restrictions. And we get the results based on what we define, how we define the building performance, the building operation, the thermostats, the heating and cooling systems. This calculates the heating demand, the cooling demand, as well as, if available, renewable energy production, as well as the demand for domestic hot water, etc. And then it calculates also the KPIs for our buildings, such as the heating demand, the load and the demand, cooling thermal load and demand, as well as domestic hot water. And finally, we can also assess the different scenarios. So in this case, One is the baseline and the other is the renovation scenario. And we can see specific KPIs that have been calculated, such as the decrease of heating cooling loads, as well as savings in primary energy consumption, heating and cooling consumption, etc. And these are the so-called energy KPIs, which are considered in the analysis, as I mentioned earlier. All the tools of the RINNO planning and design assistance are working together in order to conduct not just an energy analysis, but a multi-criteria analysis, a holistic analysis for the renovation. And then this was the process for the internal building, for the energy analysis. Once we are happy with that, we can proceed to the next software, which is the Verify platform. Again, we can make the screen larger in order to view the results better. So the way it works is basically from the left-hand side, we can see the plans and the option to construct a full project. So the tool is comprising in order to conduct the analysis, we need to set up an electrical plan, which we see here. And this considers all the electrical systems and consumptions of the building. And we can review it first, and then we can also edit it. So we can set the project lifespan. This includes information such as the project lifespan, the year of the analysis, latitude and longitude of the building, and then we can define some renewable energy systems, such as a PV, which we do here. And this involves setting the type of the PV material, the mounting system, as well as the tilt angle and the azimuth of the building. Similarly, we can set up also for a small wind turbine, or we can also include some batteries. Also, we define whether the system is grid connected or not. If the case that we're examining is consumer only or prosumer. In this case, we have a PV, so we're a prosumer. We're selling electricity to the grid. We can select the policy for the selling of electricity, and also some fixed costs, as well as the cost per kilowatt hour that we consume and we sell. So after the electrical plan, which involves all the electrical appliances and electrical consumptions, we also set up a thermal plan, and this involves information regarding the thermal components of the buildings and the thermal consumptions of the building. First, we set up the name of our plan, and then we have the floor. We set up parameters such as the floor surface of the building and the floor height, and we set up the construction, and then we consider the different heat systems before and after the renovation. Here we have set up basically what we were looking earlier. In the baseline, we have a boiler for an electrical for domestic hot water, and then air source heat pump for cooling. In this case, we're also examining at the same time. We're also setting the equipment for heating and cooling before and after the renovation. So we're defining the heating systems before and after the renovation, as well as the passive components, which you can see on the left-hand side, which involves insulation, glazing, as well as any storage for domestic hot water. In this case, we're considering double glazing after the renovation. Before the renovation was single glazing, as well as insulation on the walls. The tool for all these components has a database where we have values for the life cycle assessment and life cycle cost of these components in order to conduct the VLC and LCC analysis. So we can review our scenario, the renovation scenario. We can see on the left-hand side the renovation scenario, and on the right-hand side was the baseline, the components that were still on the baseline. We can review it, and also we can make any changes if needed. So the last step is to go to define the investment plan, which is defining some indicators, some crucial inputs regarding the economic factors, such as the VAT, inflation, electricity tax rates, the weighted average cost of capital, etc. Also, we can define if there is a loan or not, and whether if we need to also purchase the land that we are doing the renovation or not, as well as additional costs that can be included in the life cycle costing of the renovation. Moving on, we can set up construct the renovation scenario, comprise the electrical plan that we conducted, the thermal and the investment plan, and then we can conduct the analysis. So once we click the develop scenario, we can then look at it's included in this full project. So by following these steps, we're constructing a project, and then we can, in order to do the analysis, the verify tool is requesting data from the previous tool for the energy use phase of the building, and we're ready to conduct the analysis. So the setup that we did in the previous stages considers mostly the installation stage and all the embodied energy and carbon for the installation stage, and then we request data for the use phase of the building. And by clicking the Run Life Cycle Assessment, we can see the assessment of the life cycle assessment of the building during the baseline, during the renovation, as well as a comparative analysis on the primary energy savings on an annual basis over the lifetime, as well as CO2 savings that have been saved, that are expected to be saved from the renovation during the lifetime of the building, as well as a few graphs that facilitate the assessment. Following the same process, we conduct the life cycle costing, and then here we can see some cost analysis, the life cycle cost, initial investment, operational cost, etc., for the existing condition of the building if nothing changes over the lifetime that we're considering in our analysis, or during the renovation, where we see again the initial investment and the life cycle costs and the operational costs, and then a comparative analysis which shows us some financial indicators such as return on investment, the initial annual cost savings, investment payback time, etc. So following these steps, we have concluded, and we have concluded the analysis, and we can send the KPIs to the next tool of the RINNO planning and design system. The next tool in the process is the techno-economic assessment tool, and for that I would like to ask Jairis if she's available to do the presentation.
Hello, yes, I am available. Hello, everyone. Okay. Elisa, could you please make me a presenter so I can share my screen?
I can do it here.
Ah, yeah, okay. Perfect.
Yeah, so basically this is a desktop application where we, from the left-hand side, we can access the tool, and we can download it and then use it as a plugin in Revit. I have included it here, so let me know
Okay, perfect. Okay, so in here you can see the tool, which is a plugin in Revit. You can see here that we have a case study. So a one floor building, and we do have a flat roof and windows. We try to make it as simple as possible so we can show you. Okay, then we click on the TIA tool. Now in this, you will open a window in which you need to choose the name of the project, the scenario, and the start date and the end date. You also need to choose then the scenario. So for example, in this one, you will have sorry, one second. So you will have the facade insulation, photovoltaic panels, among others. Then you click on the estimated disruption and the simulation of construction waste, and it will give you an Excel file, which later in the video you will see. The most important thing when you are creating a new project is to choose the correct day, because the tool will read that day and also will read the elements from the BIM. So here you can see the Excel file, the project name that we have already pre-selected before, all the elements from the BIM model. So you can also do further calculation with this. We see the activities and also the equipment related to each activity. You can see also the difference on the different element for each part of the project. So the roof, then on this side you will see the utilities, and obviously here there is a minimum impact because we have photovoltaic on the roof, facade insulation, windows and door, so you don't have a lot of physical disruption. Mostly the physical disruption will be for the site preparation, because as you know, we have a space where we need to put the materials. Then this one is more about the activities in each floor and how many rooms it has. Then and this one is the Excel file for the waste. It tells you the waste that was generated in the project and also according to the date. So you can see here the KPIs of the waste, the average workers, and again the activity sequence. So and this is the the TIA tool, and it gives you a preliminary stage of how long a project can take, and also a way to talk to the stakeholders or also the occupants on the building, so they are aware which days the renovation are going to take place and what is the impact of the disruption from 1 to 4. Thank you.
Thank you, Jairis. So,
yes, I am done.
Using the techno-economic tool, we also, which is as far as we know, a unique tool so far. There's no similar tool that can do these calculations of the user disruption in waste management. And we use this results of the analysis, how much disruptions expect during innovation and how much waste for the selection of the optimal renovation scenario. And this is done in the next tool that we will see, which is on the left-hand side here. It's called the renovation scenario DSS. So this is a decision support system. Basically, what is done here for different scenarios, all the analysis that we did using the previous tools is now all the results are loaded in this tool here, and we can rank the scenarios. We can see all the results for different indicators. The indicators are categorized in different categories. We have environmental, energy, cost and financial, and user disruption and waste. User disruption, sorry. We have different KPIs in each category, and we can the user may also select which key performance indicators is more relevant. If they want, they can remove several key performance indicators in order not to be taken into account in the analysis. And also we can change the category weight. So if, let's say, the cost financial is more important, they can apply a higher weight. If another is not so important, you can have a lower weight. So in this case, we have increased a few weights and reduced another weight. in order to deliver, to basically to capture the user preferences. So once the user reviews the results, selects the KPIs and the weights of the categories, can click the run calculation, and it will compute the result. Basically, the software is doing a ranking and scoring of its key performance indicator, of its scenario and the key performance indicators, and computes a complete score by which it selects which is the best scenario according to user preferences, as well as a description of the renovation measures that were included in this scenario. They can review if they change their mind. They can go back, consider additional indicators if they want to consider all of them, and change the weights of the categories, and then they can recalculate. They can recalculate the scenario by initializing the values first, and then clicking the button for show calculation, and then computes a different score based on now all the KPIs and the new weights that the user may have considered. So in this case, using different preferences, this changes what the optimum renovation scenario is. Once the user is happy with this analysis, they can proceed to the next component. So what we have done so far is we have applied all the process using different tools for the energy analysis, lifecycle assessment, lifecycle costing, and user disruption waste management in order to decide to select the optimal renovation scenario. Now we're moving to the next tool, where for this scenario, we can for this scenario, we're moving on to the next tool, which is the job scheduling optimizer. We're using an automated process. We are able to conduct a preliminary schedule of our innovation. So in this case, we fetch the RINNO scenario. So we are loading the scenario that was selected previously as the best innovation scenario. And what it does is that it fetches from the database all the jobs that are considered, along with the job specifications that are preloaded in the previous tools that were used. So this is information that comes from other tools, and the job scheduling optimizer is able then to load different jobs. We can also manually include additional jobs if we want, if something was not there, and we can set what it does is work with different constraints. So each job has to be assigned some constraint, how many workers are needed to conduct this job, and what are the predecessors of each job in order which job needs to be completed for another one to start. And we can organize them also in different work packages, where a work package basically means that all the jobs in a work package will be conducted first, and then another work package can be scheduled later. So if we consider a work package that is a specific floor that needs to be finished first, we organize all the walls in that specific floor. And then we can run the calculation. Once we have set our jobs and the work packages, we can set up, and also how many workers are available and how much money is available to conduct the scheduling. We can run the schedule, we can review it, and then we can also set it we can also consider that using this layout, using these specifications, we can set it as the best renovation schedule that the user wants, and this will be then be followed during the installation phase for the tools of the next of the RINNO retrofitting manager, which is the next stage of the renovation. So this has concluded. So far, we have concluded with all these tools, with the analysis of selecting the renovation scenario and setting the preliminary work schedule for our renovation. But there's also another tool which has been developed to deliver the social assessment of the renovation, and it's called the social LCA tool. This runs independently of the others. So basically, we can access from the left-hand side as well. We see the load page here, and then we can set a new project where we conduct the social life cycle assessment of our building. We can do the analysis during the pre-renovation, the existing condition, the design phase, or after the renovation. In this case, we select to conduct an assessment for the design phase. And we set up a renovation scenario, and we can start evaluating it. So this basically the social LCA assessment includes basically some parameters, some criteria of the building in terms of accessibility, health, comfort of our proposed renovation. And basically, accessibility includes information on power and sockets. For health and comfort, if there's a possibility to measure and control the temperature in the building, whether there are potential sources of volatile organic compounds, the existing CO2 concentration, as well as the humidity inside the building. What is that going to be? As well as information on whether there is information on noise level, the daylight factor, etc. In addition, another category that is assessed is the measures regarding the safety and security. So whether there have been measures for the detachment of assault elements, whether there are solar control measures for thermal comfort, whether there's possibility of using air conditioning and ventilation systems, and whether the glass is installed, whether it is installed safety glass, fire resistance measures with higher fire resistance and load bearing capacity. Whether this is a high reaction to fire class than required by regulations, and whether building envelope exceeds the impact resistance to protect against vandalism. So by clicking and setting the parameters for each one of these categories and each one of these KPIs, we can compute the score and we can assess the social assessment score at the design stage. As this is the design stage, there's no score about the maintenance. We can then move on with the analysis, and we can, let's say the renovation has been conducted, we can do the analysis of the same building and the same scenario, but after considering the measures that have been actually implemented. So again, we're considering indicators regarding health and comfort, whether the volatile organic compounds, daylight factor regarding safety and security, again, whether there have been measures for detachment facade elements, safety glass, as well as parameters regarding the fire resistance of the building components. And depending on these parameters that we have set, we can compute our new score, and it gives us the comparison between the before and after the design stage of the renovation and the actual implemented renovation to see how our building is performing in the social LCA. So this is an innovative tool. Again, there's no, as far as we know, a similar tool developed in the market. It is based on the relevant ISO standards, a methodology from a relevant ISO standard. And this can be used to facilitate the renovation, to take into account social aspects, which is not normally accounted for when conducting some conventional renovations. And I think that is all from me for the planning and design assistant. I think we can move on to the next component.
Thank you, Vasilis. Let me share my screen real quick. Okay, you should see now. So we will present you, Christian and myself, Alexandre, the implementation tools. So what are they? So on the RRM, the RINNO retrofitting manager that you saw which is on the RINNO suite, the phase 2 that you saw during Vasily's presentation briefly. You have the on-off-site tool, the e-logistic, the e-cockpit, and the on-a-job AR and VR enabled facilitation. And the fifth, you see the 3D robot printing a bit at the right. Christian will present it to you and why the link is a bit blinked. So the RINNO retrofitting manager, the RRM, is part, as I've just said, of the RINNO suite. And the 4 tools I just told you about are all present on it. So the off-site recommendation, the logistic, the e-cockpit, and the AR/VR. And you can also add on this the planning. So this is the global interface of all these tools. We can start with the on/off-site tool. As you will see, these tools are mainly focused for the construction team, but not all of them for them. You can also use them for design, but we'll see later. So the on-site tool is really developed for the building envelope and with a focus for the facade. It helps you choose between the traditional way of building and the industrialized building. It's mainly focused for architect, design team, or construction team. And it's useful on all levels. So what you see now is the first step. So as you can see, you have 7 factors: scheduling, planning, labor, design, site characteristic, environment, organization, and cost. For each of the 7, you can put your cursor from 0 to 100, sorry. And so this score will help the tool see what factor is the most important for you. So it's really you can do whatever you want with these. You can put only one on the 100, for example, or all on 50 if you want. So it's really up to you. So then you click on Get Recommendation, and there you start for each of the 7 factors. You go a bit into details. So you have 73 parameters in global. For example, on the schedule planning, you see you have 6 factors, but they can go up to 13. And for each of the 73 parameters, you have 6 options. So you can say, for example, the early decisions are not applicable to my project. And you can go from strongly tends to build traditionally to the opposite, strongly tends to industrialize for all of the 73. So it's a complete approach, but as you can see, it has been summarized to be clearer to the manager on site. Then when you have selected all of these answer of this question, you get at the right, you see a weighted score, a global recommendation on whether the tool recommends you to use off-site or on-site. And you can have more, let's say, more info if you want for each of the 7 factors I told you about minutes ago. And then you see why it explains why the graphic on the right is like that. And then when you have this, you can go to the e-logistic. On the e-logistic, the aim is to fluidify the logistic part of the construction site and to optimize the package delivery on site. It applies to, of course, more of a logistician situation, but you'll see not only them. The goal is to have the right material at the right place at the right time. When you arrive to the landing page, if I may, you will, as of on the on-site tool, I didn't mention it, but you of course select your project and type a few basic information of it, like the starting date and end date, sorry. And then you can start the temples. So for the kitting and the component temples. There you see the form for the creation of the kit and the component. So the component is actually quite complete. So you can add it to a subtask, assign it, maybe add a subcontractor if you want, and of course the name of the component and the quantity. The goal of these two forms I just showed you is to reuse them. So once you've done it, the main work is done, and you can use them again to form package and to fluidify the whole process and change just a few, probably the quantity of, for example. And there you have a bit of a schema of how the e-logistic works between the work supervisor, the logistician, and the warehouse management. I won't go into all the details, but as you can see, you start by creating the kit, you planify to prepare them, then you go into the warehouse management. You can come back to logistician if you want, and if you check the component, for example. You go back to the work supervisor who will follow the preparation. You planify the shipping, you make the packaging tool, of course, and you end up with the work supervisor who will receive the kitting and validate the delivery, of course. We can continue with the e-cockpit. So what you see here is the interface on the RRM. As you can see, you can add your project BIM if you have one, of course. Right now, on the example is the French demo of the RINNO project in Lille, France. So the goal of this tool is to have access to all the data you either you have previously downloaded or added manually. You can see on the planning, if I may, visualize all the KPIs you see at the right, impact your project with colors, and you can do it by floor. You have 4 KPIs that we thought were relevant. So you have quality, cost, scheduling, safety, and environment. And for this, it's not 5 KPIs. Sorry, it's 5 KPIs categories, and you have inside of these categories you have 15 KPIs. And the goal of this e-cockpit, we think, can last to more than 5% to give a multiple possibility of mitigation to have early alerts before it happens. So you can reduce time and material loss, of course, and reduce time for a construction team to complete all reports, for example. I told you can download the data from your construction site directly to the RRM, but you can also add them if you don't have anything automated inside the e-cockpit. So first, of course, you log in. You have here the landing page. So you click on project data for KPIs. Right here, you will select the project, like we said before. You can, as you see, you have forms for each KPIs. And we will see right now a form. So right here, you enter the data that will later be transformed into KPIs. You can say the date it was raised, the date it was solved, so we can see how much time it was done to be solved, the cause, the stakeholder involved, and for example, the location or the status. Is it solved or not? Once you have done you have include of the data you need, the KPIs automatically calculate themselves. So that now you see a bit of a page, let's say, with few more data to have a bit of a better example and better ID. And right here you see the KPIs, the first of the 15 KPIs that are displayed and calculated here. So on the same platform that you see right above. And you can see, for example, for the safety incident, the occurrences and the week it has happened. And of course, you have this for the 15th. Moving on to the planning tool. So again, like before, you select the information of your project and of your demo site. You have a bit more of a possibility because, of course, of the planning. So you need to be a bit more, let's say, precise with the dates. Now you see the overall planning page with the level of floors, and below the Gantt will show you just in a minute. So you can add steps to your demo sites. This is the forms. So you can say you can choose between multiple rooms for each floor or not. Of course, the name of the task, where it begins, where it ends, how are you progressing with it, and if it's occupied zone or not, if it's outside or not. And once you have completed a few tasks, you get your Gantt, Gantt table that you see right here. The colors are for whether it is, like I just said, an occupied zone or not, if it's outside. So it's quite, you can quite do what you want with it and update it as you want. So of course it's updates automatically as long as you put your task in. And you can see a global overview of the work. This tool don't aim to take the scheduling job place, but more to have a factual and quick view of your project planning or scheduling. We can move on to the AR/VR tool. This tool provides relevant training and guidance using augmented and virtual reality. It's used for construction sites, so mainly, so you can use it as a manager, a supervisor, a worker, or a subcontractor also. There you can see on the screens you have multiple procedures. And so if you click on one, for example, the double layer panels insulation, you have all the steps you need to help you to prepare and to install it on site, of course. You have, if you want, photos of how it's done. You have description, of course, text descriptions. And you have, like you see on the right, animated videos doing the task for you, if I may, for every task, of course. from the beginning to the end of the task. And you also have an AR, so augmented reality tool inside this one. And you can see with your phone how you can do the task in real life, and you can place it, of course, whenever you want. So probably it's better to put it where you want to install it, to see in real life, in real time. And of course, you can move it and place it whenever you want. And that was the last tool of the RRM. And I will let Christian talk to you about the 3D robot.
Thank you, Alexandre. So as Alexandre mentioned earlier, the 3D printing robot is dotted regarding the RINNO suite, as there is some, let's say, further works to be done in terms of data, and especially the, let's say, routing of the robot that can be normally been issued from the BIM model, but currently it was not done within the RINNO project, but a further development could be done. So the idea was to test on the French demo a robot that is able to let's say print polyurethane foam automatically based on a movable scaffolding. And the robot was fully automatized and automatically moved the scaffolding according to the trajectory that was programmed. The idea first is really to speed up the process of insulation, let's say, installation, and of course to reduce waste, because there is no more cutting required, as the robot is able to print exactly the quantity, the thickness of the insulation, and exactly according to the space and the area that are needed to be protected from the thermal point of view, and also to reduce a lot the heat breach that occur when you have panel of rock wool or similar insulation materials. So just to give you an overview of how it works on these short films, the idea was to first install the movable scaffolding, which was, I should recognize, a little bit oversized, but anyway, we do this exercise with this type of movable scaffolding, which is very useful, and you can see already the let's say first printed part of the materials, and then the robot doing the printing, and at the end automatically all the wall was done from the bottom to the top, and we successfully let's say finished these tasks, and now we are developing a further solution with a robot again to let's say take the experience of the RINNO project and to develop further application for 3D printing in external insulation. So that's it from our side. Thank you. If you have any question, please don't hesitate.
Thank you, Christian. I think we can discuss questions later. So I will proceed. Share my screen again. Let me know if you can see my screen.
Yes, we can see it Vasilis.
Okay, great. So we're moving on to the final component of the RINNO suite, which is the component regarding the use phase of the building. It has a set of tools for monitoring the condition of the building after the renovation is completed, as well as additional tools that facilitate transactions and the use of the RINNO platform as a one-stop shop where we have a marketplace and facility for contracts to facilitate transactions. So we can start with reviewing the first component. First, we have again, in this case, login in the platform, and then accessing from the left-hand side, the phase 3 building lifecycle renovation manager. And this includes first a renovation roadmap, which is an implementation of a building renovation passport that we conducted for the purpose of the RINNO project. So using the tools we saw earlier for the design stage, these are all information from each of these tools. We are calculating and providing a renovation roadmap with basically the renovation that was considered in the analysis, but now with two proposed renovation paths, in case of whether the building owner does not have the ability to conduct all the renovation and want the financial ability. So we're doing the renovation in steps where we see some parameters regarding the primary energy consumption, energy, CO2 emissions, etc. in each steps, as well as the renovation measures for each of these steps. Another part of the renovation passport that is included here is the form, a database where the building owner or the person who's doing the renovation is using this as a repository in order to input information regarding the building and store it. And also this acts as a history of the building during the renovation. So we start with some basic administrative data, and then we move on to some more detailed data regarding the building systems, the building envelope, and the history of renovations. And now we're moving on to setting specific parameters of the walls. So the materials that were used, the materials before the renovation and after the renovation, so we can have a record of the building as it is now. We do this for all the building elements, for the walls, the floor, the roof, the windows, etc. We can set up different properties, different systems, more than one walls, more than one roofs, etc. And then we can also do the same for cooling, lighting, PV systems, and renewable energy sources, etc. We can save this information, all the administrative information that we saved, all the general building information. We can save it, or we can amend it later if there is any change. So we can see here that all the information that we used has been saved and can be accessed later on. If something has changed, we can delete it and amend the information. We can submit it, and then this all updates at the time that we do this change. So this acts as the renovation roadmap where we have the different stages. We propose different renovation paths, as well as a repository of all the data for the building in order to have an accurate representation of our building. And we can also download all this data in order to use it, let's say, for in a different application, if we need to. I think this concludes the part of the renovation roadmap. We're moving on to the second component of a building renovation passport, which is the logbook. So the logbook includes historical data of the building conditions, takes into account monitoring monitoring sensors and the monitoring conditions of the buildings. These are all shown through the performance dashboard. We're looking at some indicative data here for one of the buildings. At the top, we can see some key figures for the building performance, and then an analysis of the building of the various aspects for heating, cooling, etc. And also see it for different pilots. The figures here, I would say, are indicative, because as you can see, there's this highlight button where it needs to be updated. Again, we can see some main figures of the pilot, and then we can see an analysis of all the demands for heating, cooling, domestic hot water on the bottom of the page, and then results from another building. We can see again the main figures on the top, and then an analysis on the bottom. Also, at this stage, some values are outdated, so we need to review these figures as with the previous demos. But this shows the functionality of how we're using the performance dashboard. We can see some key figures here, or we can view them in a chart. And basically, this includes the information from the table in a graphical way. So in order to be able to be reviewed by the project owner, let's say, and conduct an evaluation, it facilitates the visual evaluation of the building, and includes the graphs for all the main consumption loads and production systems. Can do again the same for the various different buildings that we have in our system here. It should be mentioned that this is an account that has several cases when the user is using the RINNO suite. This is done through a user based on the user role. It has access in a specific building and a specific tools, and it's not able to see data from all the tools. The next function is again, the monitoring system basically shows information on a specific period of time where we can set it, and it shows information regarding temperature, humidity, internal building conditions, let's say particulate matter in the building, inside the building. It considers indoor, outdoor measurements as well as energy measurements. Can do the same for other buildings as well. We can select a different building, and we can see the measurements from inside that particular building. And on the right-hand side, we can see also whether these readings are inside some acceptable limits where they're shown as green, or if they are red, like the temperature here, it means that the temperature can be high, and then we can the user can see this information and take some actions. So the platform is also it is used as we can see different flats as well, but the idea is that it's used as also alerting the occupants. If, for example, we have a very high reading for CO2 emissions, we can have the occupant can review it, and it will be flashed as red, and then they can open the windows, for example. Again, here we can change the range of when we want to see our readings. We can see historical figures for indoor and outdoor measurements, as well as energy measurements. We can review this information, and then moving on, there's another component, which is the 3D viewer of this information. So here we saw the different flats. We could choose the flats and see historical data in the previous screen. Now we can load the demo, and we can see the data using the BIM, also the BIM model. It provides an immersive environment, and also better to identify the flat we want to evaluate, and we can see the real-time data the real-time readings for that particular flat. So this is another way of visualizing and facilitating the user to assess the performance of the building, the real-time performance of the building, and using real-time measurements. We can select different flats and different readings, and it will just show us which flat it is and what are the readings, and we can change the sensor, and we can evaluate different parameters. Again, we can see the whole building. And finally, the last component, which is included in the building logbook, is to provide also used as a repository of additional information. So apart from the information that the user may provide, we can also upload here and use it to store online all the data regarding the building, such as energy performance certificate. We can upload PDF drawings. We can upload the BIM file. So this is used, and it's another component for using this, storing the building information in the platform of the renovation passport. Now the next part of this lifecycle renovation manager is the marketplace. So the marketplace is a component that has been developed in order to enable companies to upload their products and be able to sell them through the RINNO platform. So what we see here is this is, let's say, a technology provider which can access the RINNO suite and enter information and also include the product in the marketplace in order to be sold to potential users. So we have users that are using the platform for conducting the analysis. We're using the analysis. We have users for uploading their information, their products. We have users who are using it in order to purchase products. So here we show the process of how a technology provider might use the platform in order to upload their products and include information regarding of how the product, what category is the product, what is the product use, and then an image, and also obviously the price and estimated delivery time. So once we do this process, the product is now added to the marketplace under the relevant category, product category. And then the user also can review it, first to publish it, and then it's live in order to be purchased from RINNO users. They can also review the information. They can edit it, change some characteristics, and update the product that they use. So now it includes another image as well. Once the product is uploaded, you can also click and can also click here and view the images of how the product looks like and how it is delivered. So once they're happy, the product now is uploaded in the RINNO suite, and then this is another user which also has access to the marketplace, but now they can only purchase products. They have a different account, and they're not technology providers, so they don't have the functionality of uploading a product, but they have the ability to review different products under different product categories, as we see here, and proceed to purchasing, to ordering and purchasing a product from the RINNO suite. So in this case, in this example, we have an insulation material. This is our obviously indicative costs that are included here. You can see the characteristics, the description of the building product, and then the user, if they're happy, they can add to cart. They can review the cart as similar to any other marketplace, select the quantity, and proceed to checkout, where they will, as we were all familiar with online marketplaces, they include the billing information, country, city where they are going to be delivered, and proceed with the payment of the product. Filling the billing information, then keeping the shipping information the same. If not, we could do the same process, and then they proceed to payment through PayPal, which is the selected method here. And then if you go to they can go to their orders, and they can review the product that they have ordered and confirm in order to send the order. So this is an additional final step in order to send the order, and now the purchase has been conducted. And also review different additional products and proceed to another order if they want. So that includes the marketplace. And finally, the last component of the RINNO suite, of the lifecycle renovation manager that we're looking at today, is the online contracts. So what this is what we are looking at here is how two users of the platform, a construction director or a contractor, can the process that they have to conduct an online contract, to sign an online contract with the project owner, with the building owner, let's say. So we have what we have here is a role. We're setting up a contract. So there are two users, and they are located in different places, but we're looking at the screen at the same time. So one user is creating a non-disclosure agreement, and this appears automatically, selecting the user, and appears automatically to the screen of the other user. They can both review the agreement, and they can make changes. So we see here one user who is reviewing the agreement, and also they can chat to each other directly. So one user is sending a chat message and appears on the screen of the other user. So there's this direct chat between the two users when they are conducting the agreement. Moving on, we can have the users. Once we make any changes in the proposed contract, in the proposed non-disclosure agreement, this appears automatically on the screen of the other, so they can review the changes that and the amendments in the contract. Once one user is finished with the editing that they want, they can click "I'm finished with editing," and once confirming it, this will then appear on the screen of the other user. So once they open their screen, again they can chat, and this will appear on the other. So let's say, I'm making some changes now. So they can review what is written in the contract, and let's say making changes. So the project is not located in Greece, it's located in Athens. Again, one change here is appearing on the other screen as well, on the other party. So Both of them are finished with editing. And once they're finished with editing the contract, then they're able to sign it. So they can review the changes that each party made, and then if they're happy, they can sign it or reject it. In this case, the first person signed it. Now the second person has signed it again, has also signed it. And now the contract appears as signed. So the process has finished. The same will appear if sometimes refresh my LinkedIn, will appear on the second party as well. So we have two parties, they're working together at the same time, they can directly chat, and they can easily and sign an agreement, they can communicate, they can review all the changes at the same time, and this is expected to speed up the process of signing such NDA agreements and facilitating the cooperation between different parties. So this concludes the presentation of the tools for the Lifecycle Innovation Manager as well. Thank you. I think we can proceed to the next stage of the agenda.
Yes, thank you very much, Vasilis, and
you.
also Alexandre and Christian for your presentations. And yes, the next steps in the agenda is to discussion time, so question and answers. So yeah, if there are some questions, please feel free to ask. Yes, please, Elspeth.
Yes, first of all, thank you very, very much for the presentation. I think it was very easy, understandable what's the use of these tools, and that's really great. One thing I wonder if you could just say 2 words on who you expect to use it. I was just considering it's not the same person using all the tools. It differs from tool to tool, or how do you see that?
I believe I should answer that. Yeah, this is a discussion that we have made before, and also has to do with the exploitation of the RINNO suite. So yeah, there are a lot of tools, and I hope you didn't get lost in too much information. And as you say, you're correct. I think it's very few organizations in Europe that would be that would find the whole RINNO suite useful. So we have, as you see, the platform is modular. So we have different stages, different components of the RINNO suite for different parts of the renovation. I would say the RINNO Planning and Design Assistant would refer to energy consultants, architects when they're planning the renovation, the tools of the sustainability experts. So this could find useful for this, the tools of the Planning and Design Assistant would be useful. For a construction company, the RINNO Retrofitting Manager, which deals with the monitoring of the progress of the construction and the installation of the components. This would find the RRM very useful. And then for the final step, this would be, I think, useful for the building owners to monitor the performance. It has the renovation passport, so it's basically relevant to the building owners as a first. And as well as technology providers who can access the marketplace, the contractors who can access the tools for conducting contracts, etc. So it's the purpose. Yeah, it's useful for different tools are useful for different peoples, and that's how we're considering now. We're considering the exploitation of the RINNO platform on how we're going to deliver different components. So it could be components of the platform, it could be individual tools also, if that would be useful. But yeah, this is the work in progress that we're finalizing until the end of the project.
Just a question about the condition of use. Is it a free software, especially on the marketplace? A company will have to pay something for pushing its products on it,
yeah, this is again has to do with exploitation, which has not finished yet. So we are finalizing, and we're on how this can be available to the public, but it has not been finished yet, and we'll have to see. We'll have to wait a few months until we decide how the different organizations are going to make the tools available. To be honest, if you, I don't know how, because this is not from my department. I'm just filling in for somebody else. So I'm not able to give you a definite answer now, but if you want, you can follow up through an email in order to see how it's going to be available later on.
Okay.
Thank you.
Are there some other question? Okay, so Elspeth.
It was just we were discussing if it was possible to share a link for the participants in this webinar so that they could test it.
Yes.
And I hope that's possible. At least I've promised some of the participants that they could.
Yeah, no, I think this is the main purpose that we're doing all of this, is that we want you also to test the tools and provide us feedback. So if you can send us an email later on, and then we can provide you some credentials in order to use. I mean, so far this process might take a few more weeks, but because we're also we're continuously doing some developments. But they can drop us an email, and we can provide them access for a few weeks in order to test the tools and give us a more detailed feedback.
Yes, thank you, Vasilis. Perfect. So if there are no other questions, we can move to the final step of this webinar. So we would like to share with you a survey regarding the tools that we show to you today. And so, yeah, Vasilis, I leave the floor.
I will share the link. So we have prepared a short questionnaire. It's not very short, but I think it's going to be fast to complete. It's based on the UTAUT methodology for assessing the acceptance of technology. So it's a unified theory of acceptance of use of technology questionnaire, and I can share the link in this Google Forms. So I kindly ask everyone to spend a few minutes in order to provide us with feedback on the use of the platform and how you found it. Thank you.
Yes, exactly. Thank you. it will be very useful for us for this final month of the project to receive a feedback regarding the platform and the tools. Okay, so we finish it 10 minutes before the end of the time schedule for this webinar. So please fill in the questionnaire. For us, is very useful. Thank you very much for joining this webinar and for your time. If there are some questions, doubts, or something else, please feel free to send us an email. And yes, we will share with you the credential to test the platform. So yeah, thank you all for your time, and have a nice day.
Thank you, Lisa.
Bye-bye.
Thanks,
Bye.
everyone.
Thank you.
Thank you.
Thank you. Bye-bye.
Bye-bye.